Hi dear students. So we have another session of Brainiacs doubt clearance, and here we have another question. So I hope you could see the question from the screen. So I will just read the question. Okay. 0.24 gram of a volatile gas upon vaporization gives 45 ml vapor at NTP in its normal temperature and pressure. What will be the vapor density of the substance? So this is the question actually. Okay, so basically how we need to do this question? Okay, so we need to know first here the relation between the vapor density and molecular mass. We know that vapor density, if multiplied by 2, will give me the molecular mass. We say molecular mass is equal to molecular mass is equal to vapor density okay, vapor density multiplied by 2. So tell me from this what is vapor density. I will use the short formula VD, stands for vapor density, and molecular mass MW I will use. So molecular mass divided by 2. So this is something you should remember, this formula. This will be useful in many places. I'm not going for the derivation. I'm only just written the formula. Okay. Now, what this question is stating? It is stating that there is a volatile gas. 0.24 gram of this volatile gas on vaporization is giving 45 ml of the vapor. So we will write that. So 0.24 gram, okay, volatile gas, we don't know what is that gas. Volatile gas gives how much ml of vapor? I can say 45 ml vapor at NTP, correct. Now to find the vapor density, now here we should know the molecular weight. So this is the clue for that. So how we can find the molecular weight of the gas here? We know that 22400 ml, 22400 ml vapor at NTP will have a mass is equal to molecular mass. So this mass will be equal to what? Molecular mass. Correct. This mass will be equal to molecular mass. Now the question here is how you can convert 45 ml to 22400. So I can say, if what you need to do, first convert the 45 ml to 1 ml. Then this becomes easy actually. So I will put this in bracket. Okay. So this is an understanding you should have. This you are learning in theory. So if you don't have a clear idea of theory, please subscribe our theory lectures. It will be very much helpful for you for your NEET exams. Okay. So we will now proceed. Okay. So here we need to convert 45 ml to 1 ml. So how we can do that? To convert any stuff or any value to 1 ml, divide by the same number. So here I am dividing 45 ml divided by 45. So dividing by 45. Okay. Dividing by 45 on equation 1. So I will say this is my equation 1. Okay. So if you divide by 45, this will become 1 ml vapor at STP, 1 ml vapor at NTP, sorry. So here, if you are dividing here, RHS divide also on the LHS. So this will become 0.24 divided by 45 gram, correct, volatile gas. Okay. Now we know that 1 ml vapor, okay, 1 ml vapor will have a mass of 0.24 gram divided by 45. We know that 22400 ml will have a mass equal to molecular mass. So how can you convert 1 ml to 22400 ml? multiply by 22400. So if you are multiplying on the RHS, this will become 22400 ml vapor, okay, at NTP. So multiply by the same value on the LHS. So this will become 0.24 into 22400 divided by 45 gram. Now what is this value? This value will be, this value, if you are calculating, this will be my molecular mass. So we will say this value is equal to, I can say that value will be 0.24 into 22400, that will come around 5376 divided by 45. So that will be 119.4, 119.4, correct. So 119.4 gram is my what? Molecular weight. Okay, so now we can find the vapor density. So how will you find vapor density? So we know that vapor density is equal to molecular weight divided by 2. So I can say 119.4 divided by 2. So that is around, so we can say 59.7. So this will be my vapor density. Okay, so now if you see, we could see the option D is corresponding to that, very much correct. So my option D is my correct answer. So I hope you have understood the explanation, and if you have any doubt, please feel free to get back. I hope you could see the question. Okay, I will read the question for you. Find the volume of oxygen required to burn 1 liter of propane completely, measured at 0 degree temperature and 1 atmospheric pressure. Okay, so you have four options given: 10 liter, 7 liter, 6 liter, and 5 liter. So we will see how to do this question. Okay, so the fundamental of doing this question here is, uh, we know, we should know how this propane burns in presence of oxygen. We know that any hydrocarbon, if you are heating in the presence of oxygen, it will get converted to carbon dioxide and water on complete combustion. So the problem here is, the hydrocarbon means they can give anything. If it is propane means, we know that propane is what actually. So I can say propane is nothing but, it comes under alkane family. So prop means 3. So it has the C3H8. The general formula of alkane is CnH2n plus 2. Correct. So in that, if I put n is equal to 3, you will get propane's formula. But the problem here is, we are the balancing the chemical equation. So that is a little bit tough when the hydrocarbon length, when the hydrocarbon is having more number of carbon atoms. Okay, so I will give you a general formula that can be used any time, so that it will become easy for you. Whenever a hydrocarbon comes, you can simply apply that. Okay, so just note down the general formula that will be helpful for you. Okay, so I can say CXHY, that is hydrocarbon made up of carbon and hydrogen, plus 2x plus y by 2 divided by 2. Okay, this we will put it in bracket. Okay, O2, that is burning in presence of oxygen, will give you x times CO2 and y divided by 2, y by 2 times water. Very important. So here, now how we use this equation general, this is a general equation. If you learn this, you can apply for anything actually. So propane means, here I can write C3H8, correct. So C3H8, So that means x is equal to 3, x is equal to 3 and y is equal to 8. So I am applying here. So C3 H8, then here what will happen? So 2 into x, that means 2 into 3, correct? 2 into 3 plus y by 2, that is 8 by 2, that is 4, okay, divided by 2, I can put it in bracket, and O2. Now x CO2 means what actually? 3 times CO2 plus y by 2. Y by 2 is 8 by 2, that is 4H2O. Correct? So this can be further written as C3H8 plus, tell me, 3 into 2, 6, plus 4, 10 by 2, 5O2. 5O2 is giving you 3 CO2 plus 4 H2O. Okay, now if you see, this is a balanced chemical equation. Then only we can apply the concept of stoichiometry. So 5 times O2, so total 10 oxygen atoms. Now if you see here, 3 into 2, 6, plus 4, 10. So it is a balanced chemical equation. Otherwise, you need to balance this manually. That is, it will consume a huge amount of time. It is always better that you remember this equation, so that if it is propane or if it is butane or pentane, you can apply it and get the balanced chemical equation. Now, which and all, what is the stoichiometric ratio now? So the stoichiometric ratio. So the stoichiometric ratio is, tell me, stoichiometric ratio is equal to 1 is to 5 is to 3 is to 4. Correct. And you know that whenever you are applying stoichiometric method, the equation needs to be balanced. Now think about which and all terms needs to be related. They are talking about given is 1 liter propane. Okay, so the given quantity is what actually? 1 liter propane. Correct. So the given quantity is 1 liter propane. Now they want to link between propane and then oxygen. Okay, so these two are the things you need to link. So as per stoichiometry, first I will write in terms of mole. So in terms of mole, tell me 1 mole propane, correct? 1 mole propane needs how much amount of oxygen? 5 mole oxygen, correct? Now we know that it is at 0 degrees Celsius and 1 atmospheric pressure. So they are talking about NTP, correct? So what is the difference between STP and NTP? STP means it is 273.15 Kelvin and 1 bar pressure. And if it is NTP means it is 273.15 Kelvin and 1 atmospheric pressure. So both are almost same. There is no difference. I know that 1 mole of propane at NTP will occupy 1 mole of any gas at STP or NTP will occupy how much volume? 22.4 liter. So 22.4 liter propane needs 5 mole. So 5 mole means 5 into 22.4 liter oxygen. Correct? Okay. Now we will see what you need to calculate here. They are asking you how much liter of oxygen is required for 1 liter of propane. Correct. So how to convert the 22.4 liter to 1 liter? We know that divide by 22.4 on both sides. So on dividing here, this will become 1 liter propane. Correct. So on RHS, if you are dividing by the same value 22.4, this will become 5 liter oxygen at NTP. Correct. So tell me 1 liter of propane needs how many liter of oxygen? You got the answer, 5 liter oxygen. Now if you see here, you could see here, find the volume of O2 required to burn 1 liter of propane. We have calculated that as 5 liter. 5 liter of oxygen is required. Understood? So the important thing to remember here is the equation, the general equation CXHY plus 2x plus y by 2 divided by 2 O2 giving x CO2 and y by 2 H2O. So if this you know, this question becomes very easy for you. Okay, I hope you understood the explanation, and if you have any doubt, please feel free to return back and ask.
One of a good question here actually. So you could read the question. The question given here is calculate the equivalent weight of nitrogen and ammonia from the below given chemical equation. Okay. So here first time we are dealing with a concept called equivalent weight. So for those students who doesn't know any much idea of equivalent weight, I will give you some intro that will help you to understand this question. So we will say equivalent weight of a substance. What is basically equivalent weight of an element? I can write it like equivalent weight, okay, equivalent weight of an element, I can say it is that mass, equivalent weight of an element is that mass, okay, is that mass that will react with, or I can say displace. Both are correct. Displace means it will be generated. That will react or displace. Many definitions are there. I can say 1 gram of hydrogen, or it can be 8 gram of oxygen, okay, or 35.5 gram of chlorine, or we can say 108 gram of silver, okay, or even I can say 80 gram of bromine, okay, 80 gram of bromine. Now which equation will suit you here? Now I need to find the equivalent weight of nitrogen and ammonia. So here what they have given is hydrogen, so we will go with the definition of hydrogen, okay, so we will go with the definition of hydrogen. So this is what we are going to use for finding the equivalent weight. Now listen here. So as per the equation, nitrogen N2 means how much gram? N2, you know that N2 is 28 gram, correct? So 28 gram nitrogen, correct? And you could see 3 moles of hydrogen. So H2 means 2 grams. So 2 into 3, 6 grams. So I can say 6 gram of hydrogen, correct? 28 gram of nitrogen and 6 gram of hydrogen gives ammonia. Ammonia, nitrogen 14 plus 3, 17. 17 into 2, 34. So I can say 34 gram of ammonia. Okay, this is what we know actually. Now how we will proceed? Now we know that first we will calculate the equivalent weight of nitrogen. Okay, so equivalent weight of nitrogen, we will calculate it. So tell me, as per my definition, if I want to find the equivalent weight of nitrogen, I need to say that equivalent weight of nitrogen is that mass that will react with how much gram of hydrogen? 1 gram of hydrogen. So as per this balanced chemical equation, what we know is, we know that 28 gram nitrogen reacts with 6 gram of hydrogen, correct? But we need to know with 1 gram of hydrogen how much amount of nitrogen is reacting. Then that mass is my equivalent mass of nitrogen. So to convert this into 1 gram, what we should do? Divide by 6 on both sides. So dividing by 6, this will become what? 1 gram hydrogen. So you divide it on both sides. So this will become what? 28 divided by 6 gram nitrogen, correct? So this 28 by 6 means it will become 14 by 3. So I can say equivalent weight of nitrogen here is 14 divided by 3. Okay, so I can say equivalent weight of ammonia. That is what we are going to calculate. Equivalent weight of ammonia. Now, as per the equation, tell me how hydrogen and ammonia is reacting. So I can say 6 gram hydrogen produces 34 gram ammonia, correct? But if you want to find the equivalent weight of ammonia, I need to know with 1 gram of hydrogen how much gram of ammonia is reacting. So how to convert this into convert to 1 gram, divide by 6 on both sides, correct? So this will become divide, okay, divide. So this will become 1 gram hydrogen, and what will happen to this one? 34 by 6 gram ammonia. Now this value will become my equivalent weight. Why? Because this value is, or this mass is what it is reacting with 1 gram of hydrogen. So this will come around how much? 17 by 3. So we can say equivalent weight of ammonia NH3 is equal to 17 divided by 3. So please remember that equivalent weight is a variable quantity, whereas the molecular weight or atomic weight is a fixed quantity. Okay, so I hope you understood the question. If you have any doubt, get back to us.
So we have a new question in front of you, and you people will be knowing the NEET is approaching. Okay, so this is one of the very good question you can expect for NEET. So I will just read the question. Calculate the amount of 50% H2SO4, that is sulfuric acid, required to decompose 25 gram of marble. Okay, so there are many things you need to understand with respect to this question. Okay, so first thing is, what is marble actually? Okay, that you need to know. So marble, I can say marble is calcium carbonate, that is CaCO3. This is the first thing you need to know. Next thing they are talking about, they are asking you to calculate the amount of 50% sulfuric acid. What is that actually? So that means 50% of H2SO4. That means we can say 50% H2SO4 means 50 gram of H2SO4 is present in is present in 100 gram of the solution. 100 gram of the solution. Okay, what is the meaning of that? You have a solution, that means there is H2SO4 with something else is also there. I think we can assume it as water. So that means in that solution, if you take 100 gram of that solution, only 50 gram is sulfuric acid. And in this question, they are asking you to calculate the amount of this 50% H2SO4. That means calculate the amount of the solution. Okay, they are asking you to calculate the amount of the solution required to decompose 25 gram of the marble. Understood? Because 50 gram of 50% of H2SO4 means 50 gram of H2SO4 is present in 100 gram of the solution. That means they are asking you to calculate the amount of solution which is required to decompose 25 gram of the marble. Okay, so we will try to understand through a chemical reaction. We know that H2SO4 will react with calcium carbonate. So how the reaction will be? Okay, I will choose another color for the reaction. Okay, yeah, so we'll write the reaction. Calcium carbonate will react with H2SO4 to give calcium sulfate, okay, plus water and carbon dioxide. Now, if you look at this reaction, it is balanced. Calcium only 1, here also it is 1, and oxygen 4 plus 3 is 7. You could see here 2 plus 1 3 plus 4 7. Sulfur 1, hydrogen 2, here also hydrogen 2. Carbon 1, here also carbon 1. So this is a balanced chemical equation. Now, we need to link between what and all things. We need to link between sulfuric acid and marble, that is calcium carbonate. So these are the two terms you need to link. Okay. Now, okay. So, okay. So now we will explain back. So as per this, what is the stoichiometric ratio? Can you tell me? The stoichiometric ratio is equal to stoichiometric ratio is equal to 1 is to 1 is to 1 is to 1 is to 1. Correct? So we know calcium carbonate and sulfuric acid needs to be linked. So tell me 1 mole calcium carbonate needs 1 mole H2SO4. Correct? But here now they are asking you the amount, actually calculate the amount. So that means mass they are asking. So we will convert 1 mole of calcium carbonate to mass, that is 100 gram. We know that 1 mole of any molecule or compound will have a mass equal to molecular mass expressed in grams. So 100 gram calcium carbonate needs, tell me, they want the answer amount of H2SO4 to decompose. They are also giving mass. So we can say 1 mole of sulfuric acid has what mass? Mass equal to molecular mass expressed in grams. So I can say 98 gram. 98 is the value. Hydrogen 2, sulfur how much? Sulfur 32, oxygen 16 into 4 64. 64 plus 32 96 plus 2 98. So 98 gram H2SO4. Okay. Now 100 gram calcium carbonate needs 98 gram sulfuric acid. But as per stoichiometry, we have how much? What is given to you? Given to you is 25 gram of calcium carbonate. So how can you convert 100 gram to 25 gram? So divide by 4. So if you divide by 4 on both sides, this will become 25 gram calcium carbonate, and that needs how much amount of sulfuric acid? You are dividing here also by 4, so this will become 4 into 2 1, so 24.5 gram sulfuric acid. Okay, so from this we understood like 25 gram calcium carbonate needs how much amount of sulfuric acid? 24.5 gram sulfuric acid. Now, but what is given to you? They are asking you what? They are asking you directly how much amount of sulfuric acid? No, they are asking you regarding a solution that has only how much amount of sulfuric acid? 50 percentage sulfuric acid. Correct. So if suppose, okay, we can say, tell it like this. Suppose, okay, suppose the solution given to you has 100 percentage H2SO4. That means the solution is completely made up of H2SO4. Suppose the solution has 100 percentage H2SO4, then 25 gram 25 gram calcium carbonate needs, tell me how much? 24.5 gram H2SO4. Correct? But here what they are asking you, but here what they have given to you, they have given to you a solution which has only 50 percentage H2SO4. Correct. So if the solution has 50 percentage H2SO4, 50 percentage H2SO4, then Okay, if your solution has only 50% H2SO4 means, now tell me 25 gram calcium carbonate needs how much amount of sulfuric acid? You, how much amount of this type of solution? You know that if you take 50% H2SO4, if a solution has only 50% H2SO4, then that means you will get only how much, half of it. So what you need to do, you need to multiply by 2 so that you will get the amount of sulfuric acid, correct? So if the solution has 50% H2SO4, then 25 gram 25 gram calcium carbonate needs double of this, because 100% H2SO4 needs only 24.5 gram H2SO4, or 100% H2SO4 means that has 24.5 gram. Now 50% H2SO4 means what? Actually you will get only half of this, that is 12.5, but actually we need how much? 24.5. That means we need to multiply by 2, so that means 49 gram H2SO4. So please understand the meaning. Here many students will get a confusion like, sir, we only calculated it as 24.5 grams and how you are getting 49 gram. Why? Because I am now talking about a solution that has only 50% H2SO4. Correct. So solution which has 50 percentage only H2SO4. So such a solution, how much you need to take? You need to take 49 gram. So if you take such a solution, which if it has a mass of 49 gram, then that is equivalent to 24.5. But if the solution is 100 percentage H2SO4, then how much is only required? Then you required only 24.5 gram. Now you can think in another way also. Suppose the solution has 25% H2SO4. So 25% H2SO4 means very like, so 25 into how much is 100%? 4 times. Then that means you need to multiply this 24.5 into 4. Okay, so I hope you understood the explanation. If you have any doubt, please get back to me. The number of electrons in 1.6 gram of methane is, okay, question looks very simple, so answer is also very simple. So but we will try to analyze the question, how to do it. Okay, so first we will talk about one molecule of methane, very important. Okay, so one molecule of methane. So what is methane? Basically methane is CH4, correct? So we are talking about just one molecule of methane. So in one molecule of methane, how many electrons are there? One molecule of methane has how many electrons? How will you calculate that? Carbon has atomic number 6, so there will be 6 electrons. 6 plus hydrogen atomic number 1, so there will be 1 electron. So like that 4 hydrogens are there, so 4 electron. So 6 plus 4, which is equal to 10. So I can say has 10 electrons. Very important. So please remember two things. We are talking about just one molecule of methane. So one molecule of methane has 10 electrons. Now, this is the basic understanding. If they are asking you regarding the number of electrons, protons, neutrons, whatever be it, always find in one molecule how many electrons are there. This you need to find out first. Then what they have given to you, they have given to is now here 1.6 gram. Now convert this 1.6 gram of methane to number of molecules. Then we know that in one molecule how many electrons, then multiply that with the number of molecules, then you will get the total number of electron. So we will see how to convert 1.6 gram to number of molecules. So we have a fundamental relationship, you might be remembering, molecular mass. So molecular mass of methane is 16 gram, correct? So 16 gram CH4 we have learned as fundamental. Molecular mass of any compound will contain Avogadro number of electrons, that is 6.022 into 10 power 23 molecules will be there, correct? Please remember one more thing, that is we can say the molecular mass of any compound will always have how many number of molecules? Avogadro number of molecules of that particular compound. okay, of CH4. Correct. Now, 16 gram of CH4 has 6.022 into 10 power 23 molecules of CH4. But what is given to you? 1.6 gram. So how to convert 16 gram to 1.6 gram? Divide by 10 on both sides. Correct? Divide by 10 on both sides. So this will become 1.6 gram CH4, and when you divide here by 10, it will become 6.022 into 10 power 22 molecules of CH4. So right now we have calculated 1.6 gram of methane will have how many molecules? How much? 6.022 into 10 power 22 molecules will be there. I know that one molecule of methane has 10 electrons. Now tell me 6.022 into 10 power 22 molecules will have how many electrons? 6.022 into 10 power 23 electrons. Correct. So I will write it in this way. One molecule CH4 has, okay, 10 electrons. Now how many molecules we have? 6.022 into 10 power 22. How we have got that? Because this came from 1.6 gram. Correct, because 1.6 gram has 6.022 into 10 power 22. Why we go for 1.6 gram? Because that is what they have asked in the question. So 6.022 into 10 power 23 molecule CH4 has. So how you have converted 1 into 6.022 into 10 power 23, multiplying by 6.022 into 10 power 23. So multiply the same value on the RHS also. So this will become 10 into 6.022 into 10 power 23. Correct? So here I have made a mistake. This is not 23. So I will just rub that. Okay. So this is okay. So you should be very careful while taking down the values. Okay. So this is 10 power 22 because 6.022 into 10 power 22. So 6.022 into 10 power 22 molecule of CH4 has 10 into 6.022 into 10 power 22 electrons. Correct. So what is the answer? You will get how many? What will be the value? 6.022 into 10 power 23 electrons. So now you know that 6.022 into 10 power 22 molecules. What is this equivalent to? This is equivalent to 1.6 gram. So that means that 1.6 gram CH4 has 6.022 into 10 power 23 electrons. That is option C. Okay. So the strategy is very simple. They can give either the mass, mole, or whatever be the case. First you find for one molecule how many electrons, then convert that mass or molecule to corresponding number of molecules. Correct. So now we know that one molecule has how many electrons. So the corresponding number of molecule has how many electrons you can calculate. So that will be the respective answer for that question. How many moles of magnesium phosphate, that is Mg3PO4 twice, will contain 0.25 mole of oxygen atoms? Okay, so how to do this question? So first I will talk about one molecule of magnesium phosphate. Okay, so I will write here one molecule, okay, one molecule of Mg3PO4 twice. Correct? So tell me one molecule of Mg3PO4 twice contains how many oxygen atoms? That is one single molecule. We know that PO4 twice is there. So oxygen 4 into 2, that is 8 oxygen atoms. I can say 8 oxygen atoms. Correct? Now Now I am going to multiply this with Avogadro number. Okay, so multiplying by Avogadro number Na. So this will become Na molecule of Mg3PO4 twice contains when you multiply on the LHS, multiply on the RHS also. So this will become 8 into Avogadro number of oxygen atoms. Correct? Oxygen atoms. Now, now what we can say, we need to convert this into moles, because the question all they are related with asking you how many moles, and they are given also in moles. So how can I do that? I know that 1 mole of Mg3PO4 twice has Na molecules. Correct? This I know, my fundamental. So I will put it in bracket. Okay. Okay. Similarly, I know that 1 mole oxygen atom, 1 mole oxygen atom has how many atoms? Avogadro number of oxygen atoms. Correct? This is also fundamental. So this also I will put it in bracket. This we have learned initial concept. Now we will try to substitute this into the equation. So here if I put this as my equation 1, I will try to substitute the formulas 2 and formulas 3 into this one. So substitute 2 and 3 in 1. How we will do that? Now tell me Na molecules. Na molecules is equal to what? 1 mole Mg3PO42. Correct. So I can say 1 mole 1 mole of Mg3PO4 twice contains 8 into Na oxygen atoms. I know Na oxygen atom is equal to 1 mole of oxygen atom. So if I substitute instead of Na is equal to 1 mole, it becomes 8 into 1 mole, that is 8 mole of oxygen atom. 8 mole oxygen atom. Correct? 8 mole oxygen atom. Now we have arrived a fundamental relationship, that is 1 mole of magnesium phosphate contains 8 mole of oxygen atoms. So 1 mole of magnesium phosphate contains 8 mole of oxygen atom. But they are asking you actually what? They are asking you 0.25 mole of oxygen atom contains how many moles of magnesium phosphate. So we need to convert this 8 mole to what value? 0.25 mole. So how can you convert 8 mole to 0.25 mole? Always I will say convert 8 to 1, then multiply that 1 with the respective number. So convert 8 mole of oxygen atoms to 1 mole. For that what you need to do, divide by 8 on both sides. So this will become 1 mole of oxygen atom. Correct. So what you have done, divided by 8. So if you have divided by 8 on the RHS, so I will mark here divide by 8. Okay. So do the same thing on the LHS also, that is divide by 8. So this will become 1 by 8 mole of magnesium phosphate, Mg3PO4 twice. Correct? Now we know that 1 mole of oxygen atom is present in 1 by 8 mole of magnesium phosphate. But the question is 0.25 mole of oxygen atom. So how to convert 1 to 0.25? We know that 0.25 is 1 by 4. So what you need to do, divide by 4 on both sides. So this will become 1 by 4 mole of oxygen atom. 1 by 4 mole of oxygen atom. So do the same thing here, divide by 4. So what will happen? 1 by 8 divided by 1 by 4, 1 by 8 divided by 4. That becomes 1 by 32 mole. I got the answer. 1 by 32 mole of magnesium phosphate Mg3PO4 twice. So now you read 0.25 mole of oxygen atom is present in how much mole of magnesium phosphate? 1 by 32 mole of magnesium phosphate. But if you see here 1 by 32, is that given in the options? No. So that means we need to do a calculation. So I will change the color and for your understanding. So here if you see 1 by 32, okay, 1 divided by 32 is what value? I will say I will multiply by 100 on both sides, so this becomes 32 into 100. So 32 by 100, how I can do? If you cut it, it will become 50, this will become 16, this will become 8, and this will become 25. So I can say 825 by 8, that is 3.1 into 10 power minus 2. That is how much? 0.031 moles of magnesium phosphate. That is option C. I hope you understood the question. This is a very important question. I hope there is a possibility that this question can come for the upcoming NEET exam, or if it is not coming, it can be for other NEET exams that is in the near future, because that this question is very good. Okay, so let's read the question. If 80 gram of X combines with 1.5 into 10 power 23 atoms of Y to form X2Y without any of the ether element remaining, then what is the atomic weight of X? This is the question. Okay, so here they are not mentioning what is X and Y, so it is not that easy. You can identify the atomic mass and get the answer. So it is just two arbitrary elements X and Y. Okay, so let's see how to find the answer for this one. Okay, so first of all, let me explain what is the meaning of if I say X2Y. Okay, I can take this in two ways. So first of all, let me say X2Y is a molecule, one single molecule. Okay, is a molecule. Okay, that is one single molecule. Okay, now tell me, to form this one single molecule of X2Y, what you needed? Two atoms of X and one atom of Y. I can say two atom of X, two atom of X, correct? Needs one atom of Y, correct? To form one molecule of X to Y, correct? Okay, now let me multiply by Avogadro number on here. So this will become 2 into Na atoms of X, correct? Atoms of X needs 1 into Na. So if you are multiplying by Avogadro number, okay, I will say here multiply by Avogadro number. You should multiply through entire stuff, correct? So 1 into Na atom of Y to form what? 1 into Na molecules of X2Y, correct? Now how we can do this? Now think about. Now I can say here just another interpretation or understanding. So tell me, 2 into Na, Avogadro number of atoms is equal to how much mole? I know that Avogadro number of atoms is equal to 1 mole, correct? So 1 mole of any substance, 1 mole of any substance, okay, will have how many atoms? We have learned this Avogadro number of atoms. So I will mark this as a formula so you can remember. This we have learned in our fundamentals. Okay, those who doesn't know this, you can contact Brainiacs Classes for the complete theory session. Okay, there we are explaining all these concepts in detail. Okay, so one mole of any substance will have Avogadro number of atoms if the substance is an atom, or if it is molecule, it will have Avogadro number of molecules, like that. So now tell me, 2 into Avogadro number of atoms means 2 into Avogadro number of atoms can be replaced by 1 mole. So I can say 2 mole, 2 mole atoms of X, correct? Atoms of X needs, needs, needs 1 mole atoms of Y, 1 mole atoms of Y to produce or to form, tell me, 1 mole X2Y, correct? Okay, so this is just for your understanding. I have explained this. Now we will come to the question actually. So in the question, they are telling 80 gram of X combines with 1.5 into 10 power 23 atoms of Y, correct? So as per this equation, we know that, so I will write, so I will mark this as equation. Okay, so I will mark this as equation 1. Okay, okay, so and this as equation 2. So, fine. Now based on the equation 1, I know that, so I will write here, based on equation 1, what we can say, you know that 2 atoms of X need 1 atom of Y, correct? 2 atoms, 2 atoms of X need 1 atom of Y, correct? 1 atom of Y. Now tell me, how many atoms of Y is being used here? They have given 1.5 into 10 power 23 atoms of Y. Now how to convert this 1 to 1.5? So I know that I should multiply by 1.5 into 10 power 23. So I can say, if you are multiplying on the RHS, multiply on the LHS also by same value, 1.5 into 10 power 23. So now I can say 1.5 into 10 power 23 atoms of Y, correct? Then this will become 3 into 10 power 23 atoms of X. So what is the meaning of that? 3 into 10 power 23 atoms of X need 1.5 into 10 power 23 atoms of Y, correct? So they have told in the question, this many number of atoms of Y has completely reacted with reacted with 80, I hope 80 gram of X, correct? 80 gram of X. So that means we have now X in two different way. We know that 1.5 into 10 power 23 atoms of Y always need how many atoms? 3 into 10 power 23 atoms of X. And in the question they have mentioned 1.5 into 10 power 23 atoms of Y completely reacted with 80 gram of X. What is the meaning of that? This means that 80 gram of X, 80 gram of X contains 3 into 10 power 23 atoms of X, because both are same. One is in the term of mass, they are telling 1.5 into 10 power 23 atoms of Y completely reacted with 80 gram of X. Other, through our calculation, we have understood that 1.5 into 10 power 23 atoms of Y needed 3 into 10 power 23 atoms of X. This indirectly means that 3 into 10 power 23 atoms of X has a mass of 80 gram. Now, that means 3 into 10 power 23 atoms of X has 80 gram. But we know that Avogadro number of atoms of any element will have a mass equal to molecular mass. So we need to convert this 3 into 10 power 23 to Avogadro number. For that we should multiply by 2. So this will become 6 into 10 power 23 atoms of X. So do it also on the LHS, multiply by 2. So this will become 160 gram of X contains Avogadro number of atoms. So if anything that contains Avogadro number of atoms means that mass is equal to molecular mass. So that mass is equal to atomic mass, since we are talking with respect to atom. So here the atomic mass of X is 160 gram. So I hope you understood the class. So what is the question they have asked you? So if 3.01 into 10 power 20 molecules are removed from 98 milligram of sulfuric acid, then the number of moles of sulfuric acid left behind. Okay, so this question is very good actually. This is actually checking whether you know the conversion between different units. So we can assume the situation like you have, okay, so you have uh, sulfuric acid taken, okay, maybe in a test tube. Let's assume, okay. Now how much is this? They are telling this sulfuric acid initially you are taken is 98 milligram, okay, and now you have removed, okay, now you have removed some sulfuric acid. Removed how much sulfuric acid? 3.01 into 10 power 20 sulfuric acid is removed. Now if you are after removing, you will be having some sulfuric acid left behind, correct? So they are asking you how much moles of sulfuric acid is left behind. Now what is the idea you are feeling? It is like very simple. Suppose you have 5 liters of milk. Somebody has taken 3 liters of milk and they are asking you how much liters of milk is left behind. Very easy, right? 5 minus 3, 2. But how you are able to do this? Because all are liters of milk, correct? But here is where the questionnaire has purposefully given you the initial mass in milligram, and the amount he removed is given in the form of molecules, and the final value they are asking you in number of moles. So here what is our challenge? We need to find the answer in number of moles. So we need to convert this 98 milligram to what? Number of moles, correct? So we need to convert this into number of moles, and we want to convert the value, the amount of sulfuric acid that is removed also into number of moles. Then it is easy for us. We can subtract the initial value of number of moles from the final number of moles to get the output, correct? So we will now focus on doing that. Okay, so now tell me 98 milligram of sulfuric acid is equivalent to how many moles? I know that 1 mole, okay, H2SO4, that is sulfuric acid, has a mass is equal to molecular mass expressed in grams, that is 98 gram, correct? So I know that 98 gram is having 1 mole, but what is given to you is 98 milligram. So how can you convert 98 gram to 98 milligram? Multiply by 10 power minus 3. So 10 power minus 3 you are multiplying. So now I can say this is equal to 98 into 10 power minus 3 gram is equal to 98 milligram. So multiply on the LHS also by 10 power minus 3. So this will become 10 power minus 3 mole. Correct? 10 power minus 3 mole sulfuric acid. Now I got the value. 10 power minus 3 was the initial number of moles taken. So I can say 10 power minus 3 mole were there initially. Now I need to convert this 3.01 into 10 power 20 into number of moles. I know that 1 mole has how many molecules of sulfuric acid? 1 mole of H2SO4 has, I can say, Avogadro number. This we have learned. 6.022 into 10 power 23 molecules Correct? 10 power 23 molecules of H2SO4. Correct. Now, now listen. Now we need to find out not for this one. I need to know in 3.01 into 10 power 20 how many moles are there. So first let me convert this into one molecule. To make this value one molecule, what you need to do, divide by the same number. So this will become one molecule H2SO4. Correct. When you are dividing by 6.022 into 10 power 23, you need to divide it, so it will become one molecule H2SO4. When you divide it on the RHS, do it on the LHS. So this will become 1 by 6.022 into 10 power 23 moles of H2SO4. Correct. Okay, now I can convert this one molecule to any particular value I need. So I want to convert this into 3.01 into 10 power 20 molecules. What should I do? I should multiply by 3 into 10 power 20. So this will become 3 into 10 power 20 molecule H2SO4. Correct? That is the easiest way. Convert the value to 1, then multiply by the respective number. You will get that. So if you are multiplying by 3 into 10 power 20, do it on the LHS also. So this will become 3 into 10 power 20 divided by, I can approximate it, 6 into 10 power 23. Then this will become moles of H2SO4. Correct? So right now I know that 3 into 10 power 20 molecules of H2SO4 has how many moles? 3 into 10 power 20 divided by 6 into 10 power 23. So if you do this calculation, this will be that number of moles. So what is this value? I can say this value is 0.5 into 10 power minus 3 moles. Correct? So I now know that the amount of moles, the number of moles removed is equal to how much? 0.5 into 10 power minus 3. Correct? So what is then finally left behind? So I will take another color for your understanding. So I can say finally the amount that is left behind, that is equal to 10 power minus 3 was initially present, minus how much is removed? 0.5 into 10 power minus 3 is removed. So what is that value? I can take 10 power minus 3 common. So this will become 1 minus 0.5, and the value, the final value is 0.5 into 10 power minus 3 moles is left behind. So this value, the amount is equal to, in moles, is equal to 0.5 into 10 power minus 3 moles. So which is that answer? 0.5 into 10 power minus 3. B option is correct. So the fundamental of this question is nothing, simple subtraction. They can, but they have given you in different units. You need to convert this into one single unit, which you need to find out the answer. Okay. So I like this question very much. You can also just go through the question. Okay. When 100 gram of ethylene polymerizes to polyethylene according to the equation. Okay. The weight of polyethylene produced will be. Okay, what is the first understanding of this question? You could understand that there was ethylene was there. Okay, n mole of ethylene was there. So it polymerizes to form CH2, CH2. That double bond got converted to single bond. Correct. Uh, Having n molecules. Now, if you see here, this question demands some respect actually. Okay, why I am saying that is, now I may say n moles are given in the question. Suppose here we start with assume, okay, assume n is equal to 1. That means what actually? 1 mole. I am speaking about 1 mole. Then how the equation changes? Equation becomes CH2 double bond CH2 polymerizing, so that you will get CH2 single bond CH2, okay, whole raised to 1. Now we know that we have taken 1 mole. Okay, so this is 1 mole. Hmm? So what is the mass of this 1 mole? Tell me. Carbon, 2 carbons are there. So 12 plus 12, 24. Then hydrogen 2, then 26 plus 2, 28. So I can say this 1 mole is equal to 28 gram. Correct? So this 1 mole when polymerizes, you are getting CH2 single bond CH2. Is there any difference here? So you got 1 mole of polyethylene. 1 mole of polyethylene. Correct? Okay. So what is the mass here? Mass remains the same. That is the important thing I want to highlight, because only double bond gets converted to single bond. So that means 28 gram is giving you 28 gram. Correct. Now, some students say, sir, you have assumed this with n is equal to 1. Why can't this be 2 actually? Okay, speak about assume n is equal to 2. Okay, what change will come? You will have 2 moles, correct? So I will write here 2 moles. Hmm? 2 moles of ethylene, that is polymerizing to give how much here? This will become raised to 2 here, correct? So this will become twice. Okay, then you are getting again 2 molecules you are getting, correct? So we are getting 2 moles as the output, or we can say what is the mass of 2 moles? It will be 56 gram. That is what is very important, 56 gram. And when you substitute 2 here, for example, I will say ch2 ch2, okay, and this is becoming 2. This is becoming 2 means there are 2 times the initial mass. So 2 times the initial mass means what is the mass actually? 56 gram. So what is the inference here? That is what is important actually. The inference here is let the n be any value. If you are taking the initial mass as whatever gram, so if it is 28 gram, you will get the output as 28 gram. If you take 56 gram, you will get the output as 56 gram. So tell me, if you are taking 100 gram of ethylene, then what will be the final mass of the polyethylene you are getting? So I can say, so, so if 100 gram of ethylene is taken, we will get what actually? 100 gram of polyethylene. Understood? Okay, so if you still have doubt, you can put n is equal to 3. Then what will happen? 28 into 3. Then output is also 28 into 3. There is no difference. Correct. So I can say whatever mass you are as a reactant you are taking, you will get the output also the same mass. The reason for that is the during the reaction only double bond is getting converted to single bond. There is no other changes. No atoms are added or no atoms are removed. Okay, so my answer should be what actually? 100 gram. I will just read the question. Volume of 1 gram equivalent of hydrogen at STP is. Okay, so again, it is based on the concept of equivalence. So we know that what is our standard definition? So we know that number of equivalents or number of gram equivalents both are correct. I have told you gram equivalent and equivalent both are same. Okay, so number of gram equivalents is equal to number of gram equivalents is equal to, tell me, weight in gram, correct, divided by equivalent mass. Okay, equivalent mass. Now what is given to you? They have given you the number of gram equivalent. How much gram equivalent they are speaking about? They are speaking about 1 gram equivalent. So number of gram equivalents is equal to what? 1. Correct. So I can substitute here 1. Okay. Have you given the weight in gram? No, they didn't give that. So weight in gram of that particular element. Okay, then equivalent mass of hydrogen. So how can you find the equivalent mass of hydrogen? Equivalent mass of hydrogen is equal to atomic mass of hydrogen, that is 1, okay, divided by valency, that is also 1. Correct. So equivalent mass is equal to atomic mass divided by valency. Okay, so tell me what is weight in gram. I have got now weight in gram is equal to 1 gram, correct? Or we can say weight in gram is equal to 1. Now what they are asking you, they are asking you the volume at STP. So I know the weight in gram is equal to 1 gram. Now corresponding to this 1 gram I need to know what is the volume at STP. But we know the standard relationship 22 point, okay, 22.4 liters of hydrogen at STP will have a mass equal to molecular mass expressed in gram, correct? So I can say that is equal to 2 gram at STP. Since it is a gas, we are talking about molecule, so that's why 2 gram is coming into picture. Now we know that 2 gram will occupy a volume of 22.4 liter, but in question what they are asking you, they are asking you regarding the volume occupied by 1 gram. Why I am saying 1 gram? Because weight in gram we have calculated as 1 gram, and this 1 gram is equivalent to 1 gram equivalent, correct? Because here we have substituted 1 gram equivalent, and corresponding to that I have calculated the weight in gram. So I need to, at the end of the day, I need to find out what is the volume occupied by 1 gram. So how can you make 2 gram to 1 gram divided by 2? So this will become 1 gram at STP. So divide on the LHS also by 2. So this will become 11.2 liter of hydrogen at STP. So I got the answer. 1 gram is occupying a volume of 11.2 liters. Okay, so what is the strategy we have done here? So we have calculated the weight in gram that is occupied by 1 gram equivalent of hydrogen. So 1 gram equivalent of hydrogen will occupy a mass of 1 gram. Then corresponding to this 1 gram, we have calculated the volume it is occupied. So we have got the answer 11.2 liter. Okay, so this is the way we need to handle questions of this nature. So if you have any doubts, please get back to us. So just read the question. 0.126 gram of an acid requires 20 ml of 0.1 normal sodium hydroxide for complete neutralization. Equivalent weight of the acid is. So this is the question here. So they are asking you to calculate the equivalent weight of the acid. Okay. So in this question we know an acid is reacting with a base, but we don't know which is the acid, but base we know it is sodium hydroxide. So we can't write an equation specific for this because we don't know the acid. Whenever you don't know how to write the equation specific to that, we always apply the law of chemical equivalence. So I can say on applying, okay, uh, on applying, the law of, on applying the law of chemical equivalence, chemical equivalence, equivalence, we can write what actually we know that an acid is reacting with the base, correct? An acid plus base will give you what? Salt. So we can say during law of chemical equivalence, I can say that the number of equivalents of acid will be equal to number of equivalents of the base, which will be equal to the number of equivalents of the salt. This is what law of chemical equivalence is stating. The law of chemical equivalence states that the number of equivalents of the reactants will always be equal to the number of equivalents of the products. Okay, so I can say the number of equivalents of acid, number of equivalents, equivalents of acid is equal to, number of equivalents, of base, correct? Okay. Now, how can you find the equivalence of acid? We have different formulas to calculate the number of equivalents. So one formula is weight in gram divided by equivalent mass. So here weight in gram of the acid I am applying. okay, divided by equivalent mass of the acid. Equivalent mass of the acid. Why I am applying this formula here? Because the weight in gram of the acid is given here, that is 0.126 gram, that is given, correct? So I need to find out the equivalent mass of the acid. Now coming to here, number of equivalents of the base. Can I apply the weight in gram by equivalent mass of the base? No. Why? Because weight in gram of the base is not given. Instead they have given normality and volume. So we have a formula you might have learned in the chapter solutions. So normality is equal to what actually? Normality is equal to number of equivalents, correct? Number of equivalents divided by volume of the solution in liters, correct? We know the definition of normality. Normality states that the number of equivalents present in 1 liter of the solution is called 1 normal. And what is molarity? Number of moles of the solute present in 1 liter of the solution. So now tell me what is number of equivalents from this formula? I can say number of equivalents is equal to number of equivalents is equal to, tell me, normality into volume of the solution in liters, correct? So I will apply that formula here. Number of equivalents of the base is equal to normality of the base, normality of the base, normality of the base multiplied by volume of the solution or volume of the base, volume in liters of base, correct? Now weight in gram, we know it is 0.126 and equivalent mass of the acid is equal to normality, how much it is given? 0.1 multiplied by volume of the base, that is 20 ml. So you want to convert it into liters, means 20 by 1000, then this will become in liters. Okay, now from this how I can find the equivalent weight of the acid? 0.126 by E acid is equal to how much this will become? I can say this will become 20. This 0 and 0 will cut off, correct? 1 by 10, so it becomes 2 by 1000 again. So I can write 0.002. Now tell me what is equivalent weight of the acid? So E acid is equal to 0.126, correct, divided by 0.002. So I'm multiplying by 1000 on both numerator and denominator. This will become 126 by 2 and that is equal to 63. Okay, so I got the equivalent weight of the acid. So if you look at the option, what should be the answer here? So I can say the answer here is option D, that is 63. Okay, I hope you understood the concept. The concept is very simple. I am applying just the law of chemical equivalence, which states that the number of equivalents of the reacting species should be equal to the number of equivalents of the products formed. So if you have A plus B giving C plus D, then I can say by applying the law of chemical equivalence, the number of equivalents of A will be equal to number of equivalents of B, which will be equal to number of equivalents of C, and which will be equal to number of equivalents of D. And for number of equivalents, we generally use two main formulas. One is weight in gram by equivalent mass. Other is normality into volume of the solution in liters. Okay, I hope you understood the explanation. If you have any doubt, please come back to us. I'll just read the question. 1 mole of oxygen molecule will be equal to, would see option A, 4 gram equivalent oxygen, 2 gram equivalent of oxygen, 32 gram equivalent of oxygen, D, 8 gram equivalent of oxygen. So this is a question related to number of equivalent. We know that number of moles and number of equivalents are two different dimensions. Number of moles are used in stoichiometric equations or stoichiometry related calculations, and a number of equivalents are used in law of chemical equivalence. So let me say what is number of equivalents. So number of equivalents and number of gram equivalents both are same. Okay. So I can say number of gram equivalents is equal to weight in gram divided by equivalent mass. Correct. So why I am saying is number of equivalents and number of gram equivalents are same means since we are using weight in gram we specifically say number of gram equivalents. So actually speaking we know that number of moles is weight in gram divided by molecular mass or atomic mass, correct? So here since weight in gram we are not telling number of gram moles, we usually say number of moles. So similar to that we usually say number of equivalents, but actually the number of gram equivalents and the number of equivalents both are one to one same. Okay, so here we will see. So weight in gram we need to find it out. So they have given 1 mole of oxygen. So 1 mole of oxygen has a mass of, tell me molecular mass expressed in grams. Since it is oxygen molecule, we know that it is O2. So weight in gram will be equal to O2 means 32 gram. Correct. Now what is the equivalent mass of oxygen? So we will calculate that equivalent mass of oxygen is equal to equivalent mass of oxygen is equal to, for any element the method of finding the equivalent mass is equal to atomic mass divided by valency. This you should remember. We are learning while calculating the equivalent weight. So what is the atomic mass of oxygen? It will come around 16. And valency of oxygen, you know that 2 more electrons are required to complete the octet. So valency is 2. So I will get a value equal to 8. Correct. So we will substitute this value over here. So we can say weight in gram, that is 32 divided by 8. So I will get a value that is equal to 4. So tell me how many grams of equivalents are there? 4 gram equivalents of oxygen. That means 1 mole of oxygen molecule will be equal to 4 gram equivalents of oxygen. So option A will be the correct answer. Calculate the number of atoms present in 1 drop of water having a mass of 1.8 gram. Now, on reading the question, we could understand that they are asking you the number of atoms, correct? They are asking you the number of atoms. Now, we know that number of atoms are asked, but they are asked for what stuffs actually? For water. Water is a molecule. So whenever a molecule is given and they are asking you the number of atoms, always the concept is actually what? The number of atoms is equal to tell me, number of atoms is equal to the number of molecules of that substance into atomicity. Correct. So this is the standard way. So what we should find out first, either we can find out atomicity or number of molecules, anything is okay. So let me find out the atomicity of water. Okay, so atomicity of water is equal to the number of atoms present in one molecule of water, and that is equal to 3. Since they are not specifically mentioning any particular atom, we say the total atomicity of one single water molecule is equal to 3. So we got the atomicity. Next we need to find out the number of molecules. Okay, for that we will just understand what it is actually. So we know that 1 mole of water has a mass equal to molecular mass expressed in grams. So 18 gram of water. So 1 mole of water has a mass is equal to molecular mass expressed in grams, and this will contain Avogadro, what actually? Water molecules. Very, very important. Water molecules. Now, now we could see here, uh, we need to relate between mass and number of molecules, because in this question they have given you mass. So we need to link between this one and this one. Now we know that 18 gram of water is having Avogadro number of water molecules. Now what is the mass? They have given to you 1.8 gram. So how to make this 18 gram to 1.8 gram? Divide by 10. So this will become 1.8 gram water molecule, and to divide it on the RHS also, this will become Na by 10 water molecule. Correct? So here the advantage here is, if you see, uh, 1.8 gram of water will have how many water molecules? Na by 10, Avogadro number divided by 10 water molecules. So we have found out 1.8 gram of water has how many water molecules. Now we need to just substitute in the above formula. So we know that, again we are doing it, number of atoms is equal to number of molecules, that is the number of molecules in 1.8 gram of water. How much is that? Na by 10. So we know that Na by 10 multiplied by atomicity is 3. So how much we will get? I will get an answer 0.3 Na. So what should be the answer here? 0.3 into Na means Avogadro number, 6.022 into 10 power 23. So my answer is option A. So I hope you understood the question. If you have any doubt, please come back to us.